Hello, my name is Jack Fields. I am a student at American Heritage School in Boca del Rey, and I have been using the HPC Systems Generalized Neural Network bundle with TensorFlow to train a model to find known faces leveraging the Robotics API. Abstract. Cost-effective campus security at all levels of education is in high demand at schools around the globe. Solving this problem with the use of robotics in a manner in which can be shared and implemented in a universal platform would most benefit a larger populations of students than a technology-based program or software that would cause economic discrimination. HPCC Systems is open source, which will allow any entity to benefit from its resources. Secondly, a program needs to be created in which does not preclude most end users from the ability to use the finished product. User compatibility with technology already in place and user friendliness based on a traditional or expected skill set would serve a much wider client base. HPCC Systems GNN Bundle. The HPCC Systems GNN bundle was utilized with TensorFlow to train a model to recognize known faces. Robotics implementation in HPCC. Number 1. Ingesting or spraying data into HPCC systems. Second is actually processing this data. And third, in the future, where we hope we can use Roxy to query this data, to use a trained model to display live results. TensorFlow is an open-sourced artificial intelligence library that utilizes data flow graphs to build models. TensorFlow was a perfect solution for this project because it is meant to be used with large-scale neural networks. Before I started using HPCC systems, I thought it'd be a good idea to get a test outside of the platform. Since the GNN bundle was relatively new, I wrote a program in Python that would use TensorFlow to train a model. This gave me accurate results to compare to when actually using the GNN bundle. ROS Operating System 14. ROS is an open-sourced, flexible framework for writing robotics software. ROS can run on almost any system, but for this project, I'll be running it on a Linux machine. The most up-to-date version of the Robotics API can be found on the Stallion Robotics GitHub page. A lot of updates were made, including making it work for the newest ROS version, as well as making it work for the newest robot code version. The steps. The first step was to figure out how I could actually collect the data. It's not like a camera can detect a face on its own and take a picture, crop it to size, rescale it, and do anything you want to it. So I developed a software that will allow a person to scan themselves into the robot. This works by prompting the person for their name and then taking a series of pictures of them using a camera placed directly in front of them. I utilized OpenCV to detect the location of the person's face, as well as to automatically resize and scale the images to universal format. The software also converted the images to grayscale, making the images one dimension and easier to work with in the future. Next, I used a convolutional neural network, CNN. This will allow me to go through a series of convolutions where it takes the data from an image and creates a feature map and pooling where specific regions are selected, and then the maximum values are extracted and then used as the entire selected area. You can view the graph in the poster right here, and this should give you a basic understanding of how this works. Project applications. The Robotics API was designed to allow anybody interested in robotics to spray the robotic sensor data into HPCC systems. This will allow for universal applications throughout existing global security setups, cost effectiveness, open sourced, obtainable HPC systems, trusted and reliable LexisNexis.